All right, so let's add different denominator fractions. The key, in my opinion, is to set the problem up correctly and to prevent yourself from making silly mistakes. So I'm not calling anyone out here because we all have our process, but I recommend that you use this process and not this process, because in terms of writing your fractions, because you're less likely to make mistakes, because you're looking directly across, there's no lines in between, it's just like 1 plus 1. Well, actually you have to find the lowest common denominator first, but if you're multiplying fractions, for example, which we'll go over in a future video, it's just easy to see. However, if it's easy to see for some people, then this is fine. So I'd recommend, if you're going to add or subtract fractions with different denominators, you've got to find the LCD. What is the LCD again? You probably already learned this. You might have. Maybe this is a sort of a refresher. It's the lowest common denominator. So 2 or more fractions. So we got 2 fractions here. So the process is to start with the largest denominator, so 4. Check to see if the other denominators go into 4 evenly. 3 does not go into 4 evenly. There's a remainder, right? So then you take that 4, right? That gets crossed out. Now you double it. And then you check. Does 3 go into 8 evenly with no remainder? Right, it doesn't. Now we go to 12, which is just 4 times 3. So now we know, since this is 4 times 3, we know that 12 is our LCD. So 12 is our LCD for this addition problem. So we're going to do 12 and especially when you're just getting started or when you're just getting back into the flow of things, let's say you're going back to school, as an adult after a long hiatus, or let's say you're just learning this when you're really young. If you need to go back and show a little bit of work, it's generally a plus. You don't have to show your work if you can do everything in your head, but sometimes you need a little help. So, we all need a little help sometimes. It's like a life mantra. So 3 times 4 is 12. So remember, you're keeping the fraction the same. Whatever you do to one part of the fraction, at the denominator of the fraction, you have to do to the top of the fraction. So where the multiplier is, times 4, 12 times 4. So 1 times 4 is 4. So to keep the fraction the same, remember, because it's 1/3 equals 4/12. So we do the same thing here. And again, I would recommend you do this, make this little box, and do this for the numerators. It takes, 10 extra seconds, but I think it's helpful, especially when you're getting back in the mix or when you're really learning this stuff. Eventually, you won't need to do it. It'll be super fast. You won't need to do it at all. So 4 times 3 is 12. 1 times 3 is 3. But don't feel bad if you got to do it. Feel good if you got to write stuff down. Feel good if you can do it in your head. Feel good if you can check the answer with your calculator. You want to use these resources, these tools at your disposal, and you want to go the rigorous road. Generally more rigorous. You don't want to go for the easy path, especially when it comes to learning. But you don't want to go too crazy either and have something be like so hard that you're just so stressed out. So, it's obviously not a simple rule, or simple recommendation, but generally you want to go towards a little bit more rigorous. So, but in terms of process, I like writing it all out. So now adding fractions. You could probably see these would probably be fine. What I like about writing it out this way is it's just much easier to see. However, what I did when I was young is the the adding and subtracting of fractions, once I got the LCD, I put them in this form, right? Everything straight out. Or excuse me, multiplying or dividing fractions, right? Which we'll do on future videos. But for adding and subtracting fractions, I would do vertically instead of horizontally. And so just trying to remember that. It's going to be numerators only, so 4 plus 3 is 7. 7 over 12 is our answer. Obviously, it could be easier to see here. 4 plus 3 is 7. The numerator changes, but the denominator stays the same, which is why we got the LCD, right? That was the reason why we got the LCD. We solved for it, is so we can keep that denominator the same. But hopefully this is helpful in terms of adding fractions with different denominators.